Here is the foundation plan for 2030 Pinecrest Court. It is a fancy custom house, new house to be built. Here are elevations of the house. So there's the front door. Notice single story, only a single story of windows and then a steeply sloped roof. I can tell it's steeply sloped by how tall it is. Maybe not that steeply sloped, but okay. So then here's a side view, and we can see there's the front right there. So when you approach the house from this side, it appears to be one story. But then when we look from the side, we can see that the lot slopes down like this. Here's the garage. Okay, so that would be structurally 2 stories. Only the top level is occupiable space, habitable space. The ground floor is just a garage and a crawl space. Here is another side view, another side, and so here we can see there's the driveway coming down into the garage, which I just pointed out. These are doors and windows into the garage, and this is a staircase that leads up into the garage. It's a rear view rather than a side view. It's the back of the house. Okay, and then there's the other side. And then here's a deck on the back side. There's the front side with the steps down to the front door. Let's look at a plan view. So what we can see here is a covered deck. So where's the front door? Here. These are the steps that go down to the front door. And then, regarding that lower floor, the non-habitable space, here we've got 2-car garage. Right in here, these are 3 garage doors. There's a staircase in the garage that goes up to the house. It's up like this. And then this is crawl space. And I'll show you what that looks like, but it's just sloping earth exposed if you go underneath the house. Crawl space, crawl space, crawl space. And habitable and covered deck. So there and more deck. So there isn't a living room down at this level, for example. The crawl space looks like this. So here's a section through the house. We can see the upstairs has furnishings. It's got doors, and then here I'd read these things. We can get rid of these. Under the house is just rough space. Just a tall crawl space. Because this house it's going to be sitting on a hill. See how the land slopes? The house will be sitting on a hill. We'll use what's called a pile foundation, which is concrete columns that extend down into the soil, and they go deeper than they're shown here. They actually go, I don't remember if it's 10 or 15 feet down. So my goal right now is to draw some foundation details. Let's go to my plans. Here's a layout of the foundation. Every one of these circles is an 18-inch diameter. I think it's 18. Is it 18? I have it drawn as 24. Okay, I may reduce those to 18. 18 or 24-inch diameter concrete column extending down into the soil several feet. And then those piles have to be tied together with what's called a pile cap, which is a big pad of concrete. And the pad of concrete is indicated by this outline. And sometimes it's not a pad of concrete. Sometimes it'll be like for a narrow row of piles like this, what's called a grade beam. So it's a concrete beam at grade level. Here's a section 18 detail 18 on sheet S3.0 is a section through this foundation, and this is actually a retaining wall. Right here, it'll be more clear when I go to the section. Let me look at the section. So here what you can see is here's the retaining wall. These are CMU blocks, also called cinder blocks. And then here is the pad of concrete that I referred to. So that's the foundation. And here are the piles, the concrete columns that extend down into the soil. And this curvy line just indicates, it's a break line. It just means the pile does continue down deeper than I'm showing, but I'm not going to draw it. Because the piles would extend down off the page if I drew them in their full size. Who is text messaging me? Okay. Anyway, so that's the footing for a retaining wall, and it's also called a pile cap. It's acting as a pile cap. We don't want just piles free floating in soil where you have a concrete column in the soil but there's nothing joining it to the other piles, because if you have single piles floating around in the soil, they can move off, they can move sideways. Okay, so what you're seeing when you look at this foundation is piles, and then you're seeing a system that ties them together. Now here, what we can see is this line that I've just highlighted. That is a step down in the foundation. Here, I'll move this over. We need to indicate that so the foundation contractor knows the foundation steps down. The reason for that is that the foundation of the house is going to be at a certain elevation, and the foundation for this retaining wall, here, let's draw this. The foundation for the retaining wall is going to be a little bit lower, and the reason for that is so there can be soil covering it. Right, so notice this soil that's on top of the footing of the foundation wall. If I don't put that there, then you're just going to have an exposed concrete platform, which is ugly. And if I put an inch of soil on top of that to cover it up, then nothing can ever grow there. No plants could ever grow there, or a garden. So I put enough soil, I'm putting 18 inches of soil, enough soil on top of that so that someone could plant a garden there and have some decoration if they wanted landscaping. A tree is not going to grow there because there's not enough depth for the roots. So what's happening though is that the house's foundation is at one elevation and the retaining wall foundation is at a lower elevation, so we need a foundation step detail. I've started that here. Let's give it a correct label. Foundation step detail. I don't even say detail because everything is a detail, so just call it foundation step. Everything on these sheets is detail, so we don't need to call it, I-joist stiffener detail, typical strap schedule detail, sill plate notch and bolting detail. Right? We don't need to say that. Okay, but this is the beginning of my foundation step detail. Right now, let's go back to the plan and draw our CMU wall in. Let's we can just use the S detail layer. So I will draw the outline of the wall like that. And then I will use the offset command, the thickness of the wall. So I hit O, or select the object I'm talking about. Then O, enter, and then AutoCAD is saying specify the offset distance. 7.62 inches is the thickness of these blocks. So I've drawn the thickness of the wall at 7.62 inches, and now I'm going to fill in the end here. Maybe this goes like that. Right, and then we'll fill in the end right here. Like that. Okay, it's looking like a respectable CMU wall. I do want to infill it with a CMU diagonal line hatch. So I'll just click on any fill, it doesn't matter. See what's happening though? It's filling in around the piles. That's not what I want, so I have to click in all these spaces. Okay. And now let's change this to a diagonal line, just a simple diagonal line pattern. There you are. Okay. And it's so fine. See how it's so close together that when I zoom out, it just looks like a solid fill. So I click up here and I'll change this. Maybe you can't see it because it's kind of faint. Hatch pattern scale. It's set to 1. Let's try setting it to 10. Right, and now you can see the lines are a little more spread apart. Let's spread that. Let's do that a little more. So this, there we go. Maybe a little closer than that there. All right. So now when someone looks on the plan, they can see Okay, they can see there's a wall, and here's the slope. I want these lines to be at about 45 degrees when inside the wall, like between the parallel lines of the wall. So I'm going to use angle. See, I can use the angle slider to change the slope of them. This looks about right. And what that means is the angle will not be right over here in this piece of wall. So for a moment, I'm just going to draw a temporary dividing line here. Highlight it, use trim, TR, and I'm going to trim the hatch pattern out from this side. Okay, get rid of my dividing. Oops, let's keep it there actually. And now we're going to fill in this side so it's like filled in separately from the other side. Okay, and let's put a line in there. The spacing I think was 45, and then we want to change the angle so that we're at about a 45 inside this. There we go. Bingo. See, 45 in both. Looks good. Now that was a bit of work, so let's save. I right click on the file name up here, right click and select save. Let's save it. I really don't like losing work, and sometimes when we when we do our work, then the computer just shuts off sometimes. Okay, so I've saved, I've drawn my CMU retaining wall. Oh, and then if I look at detail 18 on 3.0, so the wall, the detail, here's a cross section through the wall, and it says CMU wall, that's concrete masonry unit wall and bars per plan. Notice I do not indicate the thickness of the wall here, nor do I specify the bar size and spacing. I show the bars, but I don't specify what size and spacing they're at. That's on plan, it's to be on plan, so we need to put it on plan here. So let's grab this, swing that over here. This can be there, and then point at the wall. And notice how, see how closely the arrow points? I'll even bring that right up to the wall. I really like to get these leaders or arrows pointed right at the thing that they're talking about. I don't love it how this is so far away from the wall. So maybe we can bring it back over here to be closer to the wall like that. Very good. Okay, and this is going to be 8-inch CMU wall width number 5 at 32-inch on center vertical and horizontal. And I'll check the design. I'll do a design of the retaining wall and see if we can use even smaller bars than that. But for right now. Oh, and then I'm going to write grade 60 number 5 bars at that, right? I like to be very explicit about the bar grade because there are grade 40 bars floating around out there in the world. All right. Okay, and then this footing, we need a footing call out. I've already made an entrance in an entry in the footing schedule, type G4. Here, oops. So it's G4. So I need to go grab a footing schedule from the plan, a footing symbol from the plan. Here. G, we'll take that. G1, copy it, Control C, go over here, Control V to paste, right, and then change this to G4. And let's center that a little bit. That's my being over the top. Okay, if I like things to be really centered. G4, okay, and if we notice, go back to the footing schedule, G4 says in this footing size, right? If your footing is just a square viewed on plan, then you can say it's 2'6" by 2'6", and then it's 24 inches thick. But if the footing is a weird shape like that retaining wall footing was, I just say per plan, because I have to show the dimensions on the plan. I can't conveniently describe this shape other than by showing it graphically. So I will go into the toolbox and I will grab here some plan dimensions, copy, Control C, paste, there it is. And now let's bring these over here, and we want to rotate these dimension lines to be parallel to the sides of the footing that they are measuring. So I highlight this, I tap RO for rotate, hit enter, and it says specify base point. That means like what point are you rotating around or about? I'm going to rotate right around the corner, roughly where I think the corner of that footing is, and then I rotate like this. And notice if the rotation like lever, I'll call it, is short, the rotation is extremely sensitive, right? Tiny movements with my mouse cause this thing to swing around and around. But so it's going to be hard to get it adjusted just right. But if I bring the mouse out like this, right? Phone making noise again. Okay, stop. If I bring the mouse out like this, I have much finer control over the rotation of the dimension. So I'm going to align that pretty darn closely with the edge of the footing like that. Good enough. Okay, swing this over here, and then I'm tapping O3. Watch my O snap thing at the bottom right of the screen. Ready? O snap. See that? I can turn O snap on, off, on, right, with F3. Right? I want to snap my dimension line to the corners of the foundation that I'm being specific about. Turn off O snap now, okay? And now I'm going to use CAD to measure this edge of the footing here. It says 8 feet 3 1/4. Okay, so I'm going to ignore that 1/4 inch. It's just not a significant amount of length. So I'll just say 8 foot 3. And this is a case of flying away again. Like, you know, why don't I have the dimension be all the way out here, right? See that? Because it's stupid. Why put the dimensions so far, arbitrarily far away from the thing that you're measuring? Let's bring it in a little closer, like that. Okay. And then we need to put a dimension on the other area. Here, we can delete that. And then we need to rotate. So I can actually, let's try this. Up here, I go to measure, and I click the drop down. And I click on angle. And then I click these two lines, 1, 2. And it tells me the angle between those lines is 131. So how about I highlight this, I type RO for rotate, hit enter, click anywhere on this, and then type 131, enter. Right, and that rotated this so that now it's already ready to attach to the footing, like that. And it's parallel to the edge of the footing. We need to move this over here because we're telling the contractor like that. Okay, where how long this footing is. Okay, and let's see, how long is it? So I want to measure distance this time, straight line distance, not an angle. So I click the measure drop down and I click distance. I've still got O snap on. See these green shapes that are popping up as I float the cursor around? That's O snap saying, are you talking about this point? Are you talking about here? Here? I'm going to measure from here, this corner of the foundation, over to that corner. 15 feet 3/8 of an inch. Let's just call that 15 feet. 15 feet. Contractors don't want to pour big foundations considering 3/8 of an inch. Concrete work is just not that precise. Here we got a conflict between the dimension line and the detail reference. I hate conflicts of that type. So let's move that out a little bit. Now I'm going to make an obvious mistake. Let's say I move it out and I don't move it out straight, right? And then I want to extend the dimension line to be in, the detail line to be in contact with the detail bubble. Highlight that, hit EX for extend, hit enter, and then I touch this line and it extends till it hits the circle. That's ugly to me. I like the line to go all the way like to the center of the circle. I mean, like to be aimed at the center. I don't like, I aim things at the centers of things usually, right? So you won't see me do like this, because that's just pointed at some arbitrary part of the detail circle. So what I'll do is this, I want like that, all right? Good enough, okay? And then here's a conflict too. See how these lines overlap? This is messy, it's ugly. So I'm going to move this out here. Again, we were going to use extend. So I highlight that, the extension boundary, hit EX, enter, and tap the line or like inclusive select across the line, and that activates the line and extends it till it hits my extension boundary. Then I click like that and it's done. Now here's something I've seen young drafters earlier in their career do. They'll put a call out like this, or a specification, we'll just call them call outs, okay? The footing call out like that. Notice which one of these footing call outs is right. You can guess the one that I drew as an example is wrong, okay? Notice that this call out is pointing at the edge of the foundation. This is the edge, and in this area is the foundation. This is the body of the foundation in here. This is pointing at the edge of the foundation. It's pointing at the foundation. Okay, I'll draw a little arrow to aid in understanding that. This is not pointing at the foundation. It is, yes, it's pointing at the edge, but it's really pointing at the edge of air. Okay, that's not the beginning of the foundation, that's the end of the foundation, and beyond it is the air. So you get it. I like to point at the thing, showing like where does the foundation edge begin. So as we work our way from air, we hit the foundation right there, and then everything beyond this is foundation. And notice my CMU wall call out it's pointed at the wall. It's not pointed. If I do this, let's say I point the CMU wall thing there. Yes, I'm pointing at the edge of the wall, but it's like I'm really pointing beyond it. It's like, well, what is out there? Not the CMU wall. It just seems wrong. So I point things like that. Okay. We've done some work, so let's save that. We never want to lose that work that we did. And we need to call out one more dimension. Let's do the same trick. So measure, angle, click these two lines. 162 is the angle between them, so I'm going to copy and paste this with Control C. And then I type RO for rotate, and this time I type 160, how was it, 162? I guess so, 162, negative 162, because we're going clockwise, counterclockwise. There we go. Let me check that again. Was that 162? Yes. Okay, good. Now I'm going to use O snap, turn on O snap, and I'm going to type M for move, and I grab this piece right here, and we're going to move it to there, to that interior corner. When a corner is like an armpit, where it's not a corner that's sticking out into space, it's a corner that is sticking in like an armpit. That's called an interior corner. Okay, I'm going to adjust the boundaries of the dimension like so. And are we going to get a little weird conflict here? See how this is weird? It's not clear what exactly is referring to what. So we need to fix that. Let's move this with M, enter. Just move that out of the way for a minute. And how about this? There. It's not real clean, but it's better. You can see this dimension line is extending and talking to this measurement. Okay, so that's better. And then I'll bring this over here. Let's turn off O snap now. And then what's this? Oh, leave O snap on because we're going to measure this distance. Scale this distance. 5 foot 10 and 11/16. That's a yucky dimension. So what I'm going to do is just say that's 5 feet 11, give or take, right? Plus or minus like that. Okay, and now we need to bring our footing step down indicator back. That could fit right there, I guess. Right, and I move the leader line to be pointing at the step. Oh, see what O snap did? It thought I was trying to send this leader to the mid line, the midpoint of this line. So let's try that again. This time I'm going to turn off O snap. And notice this has erased the landing of the leader. Remember, I always like to have a little bit of slope in the line so that we can see where the landing is. It's just an aesthetic thing. And that's kind of flying away, right? Should it be out here? Should it be out here in outer space? No, right? Should it be so close that the arrow disappears? No. So let's put it right about there. That's fine. Oops, oh, we want our arrow back. So go a little farther. There's the arrow. Perfect. Okay, that was some work, so I'm going to save that. All right, now let's draw our footing detail. Footing step 18 on S3.1. All right. So we go over here. Oh, what I'm going to do first is I'm going to make a screenshot of this. You can say I already did it, but I'll do it again. Okay, so I take a little screenshot of this area for reference, and then you can't see it because I have a multiple monitor setup, but I'm going to pull that off onto one of my other monitors so I can keep looking at it. If I leave it on the same screen here while I try to draw, it'll keep getting hidden every time I click on AutoCAD. So, okay. We need to get you a multiple monitor setup. So let's go to detail 18 on 3.1 and draw the detail. I'm going to start from scratch. Now I know that the detail on the left, the footing on the left, being this footing here, is 24 inches thick. Let me see what is it 24? Yeah, it's 24 inches thick. Let me just check my foundation schedule. I don't want to draw this thing more than once. Yeah, 24. Okay, and the other one's 18. The retaining wall one is 18. Why would the grade beam foundations be 24 inches tall? The reason for that is... Let's check the geotechnical report first and just see if it mentions a minimum grade beam depth. We'll bring this up here. Come on. Pinecrest geotechnical report. There it is, geotech report. I click on that and I want to go to, let's do this. Foundations, right? That's page 13. Foundations. Okay, provided the blah, 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 I'm looking for a dimension. Pier depths of 5 to 10, right? Retaining walls should have a minimum diameter of 18 inches for the piers and extend a depth of 5 feet into bedrock. Okay. Designed on the basis of the end bearing. Okay. Piers should be a minimum of 4 number 6 bars. The grade beams should be reinforced. So let's make sure my piers have 4 number 6 reinforcing bars specified. I go to the footing schedule. What? I don't even have my piers here. Okay. Piers aren't even indicated there yet. Awesome. Really? All right. Cool. So here, let's bust that out. Piers, I always indicate with P. So we'll do like this. I'm going to put this here. P1, pier type 1. Move, M for move. Right, and have this pointing. See how it's pointed just into a random zone right there? I don't do that. I point it at the edge where an object begins. So that's P1, and I'm going to indicate typical. Grab that and copy it and paste it right here. Because I don't want to have to, whoops, over here. See, if I put tip right here, it's not clear whether the typical is referring to the P1 or to the detail 16, so I'm going to put it over here. Clarity, right? Tip, like that. I don't want to have to write P1 next to every one of these piers, piles, piers, same difference. So P1, and then I need to go make an entry in the foundation, the footing schedule. So I'll highlight this stuff. Whoops, nope, wrong button, okay. Let's move this with M. I use O snap, and I'm going to grab from here down to here. Okay, and now I highlight this stuff, and I use CO for copy, and I do from here to here. Boom, like that. And now I need to extend those vertical lines down, so I highlight this as my extension limit edge, EX, enter, and then I inclusive select across these lines. Maybe, oh, here I can even, yeah, there we go. Boom, 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 like that, see? Right, and now I change this to be P1. P1. Very common for something to be off center, so let's fix that. Right, and then if I go into the company standards, and I open up phone making noise again, company standards, and I go into schedules and notes. A footing schedule is a schedule, so find schedules, and I can look for an entry that has to do with piles. Does this have a pile entry? Geez Louise, how do I not have a pile entry? Okay, let's make one. Okay, so what things do we need to know to define a pile? Okay, we'll call that P1. I'm putting this in the template, so in the future I can just copy and paste this into other projects. Right? We need, instead of like on plan view, it's not like a square footing where you have 2 foot 6 by 2 foot 6. It'll be a diameter. Right? So let's write 24 inches diameter. Okay. We need the reinforcing the bars, so that'll be, per the geo report it was 4 number 6s, but I like to go with 6 bars because that makes a better vertical cage of bars to wrap the circular closed tie hoops around. And those are the long bars. They go the entire length of the here, like this. And then depth, the geo report said 10 feet min into bedrock. If they want to go further in, they can, but that's called work. Let's just double check that. Should have a minimum diameter of 18. I put 24. That's even better than 18. And extend a minimum depth of 5 feet into bedrock. Oh, okay. So I did overkill. Right? So 5 feet min into bedrock. There we go. And then the capacity, I'm not even going to worry about filling that in. Okay, so P1. Now let's just copy and paste this. Control C. I go back over the file I'm working on. Right. There's that entry. So we'll delete this stuff. Alright, and I'm going to use, I have OSNAP on with F3, and now I'm going to use copy, CO, enter, and I OSNAP to the end of this line, and I move over and I OSNAP to the end of this line right here. See how it puts things nicely into place? Click, there. Then delete this, inclusive select, delete key, and then I notice that this is off center. So let's move that, and notice OSNAP is trying to take this like over to snap it to weird stuff. I don't want it snapping. I'm going to eyeball this. So use F3 and I put it right there, like that. Okay, footing schedule looks good. This footing schedule is viewported onto the foundation plan, so I made the footing schedule bigger, and so now probably part of it's cut off on the plan. Yeah, see this blue box is called a viewport reference. I'm going to extend that now to make room for the additional depth, right? Height of the footing schedule that I created there. So now the whole footing schedule and its notes are visible on the plan. I never got around to detailing the foundation step. I could do that in another video. I don't want to make this video so large to upload that it takes all day. So we'll do another video in a bit.